Yes.
Okay, you can hear me. Good. Hi. So, as you know, maybe the most fun part of this workshop is these various projects, and we've actually tried to make them organized. We actually thought about this beforehand, and tried to organize it around measurements that were made in last summer in the 2018 monsoon. And have a number of ways of looking at the monsoon. Although because we're oceanographers, we're really looking at the ocean because we don't know much about the atmosphere. So it's a little bit weird, but okay, that's the way it's going to be. So this is an old legend of the 6 blind men and an elephant. Okay, so there's the elephant, right? And here are the 6 blind men. That's why we have 6 projects. Maybe. Just was convenient. And so you can see each of them is looking at the elephant in a different way, and they think different things about the elephant. And in the same way, we have 6 different projects in which we'll be looking at different ways of thinking different measurements of the monsoon. And the hope is that these will converge in some way, or at least give you some idea about how these different ways of measuring give you either the same answer or different answers. And the hope is that when we're all done with this in a few days, there'll be some synthesis, and that synthesis will be something we can communicate to this workshop about the 2018 measurements in this synthesis. So the hope is to try to do individual projects, but also work together. So that all sounds very idealized. Emily didn't get a chance to talk about this, but she does now get a chance to talk about this almost immediately. So I'm going to invite the guest speaker, Emily, to the stage here, and she's going to sing a song for you. Now, you want to just work off of this? Is that sufficient?
Try to do that.
Okay.
See my dates.
Okay. So the point of this is that there was a perhaps well thought out set of experiments last summer, and much of this will go into the projects. So you can talk about it first, and then I'll fill in the things that you didn't say.
Okay.
And there's a
So just quickly, because our theme built around the first year's Miso Bob cruise, and so just a quick summary of what we did. We left Chennai. I have to look at my dates here. I think on June 4th of last year, 2018. And then the ship steamed across to the eastern Bay of Bengal. We have to stay in international waters, so that's the black line you see around here. The ship was kind of set in the context of these other moorings. So NIOT has a set of buoys that they maintain. Those are the gray diamonds here. And then the Rama array are freely available data for anyone that's interested in using them. Those are these stars here. But the ship, we essentially had the ship as a platform, but then we also had a drifting buoy that had atmosphere and ocean measurements on it. And so our thought is we would position off of this 15 north Rama buoy and sort of form these diamonds, basically, or triangles where we have the mooring close by, we have the ship running around. One of these is the buoy, the red diamond, and then the other, we also had a drifting wire walker, which is just a profiling. It's just ocean measurements. And so these two things are freely drifting, and then the ship was kind of just trying to maintain its position with that set. And we basically did 4 drifts because the ship gradually would get far away from those other systems, and then we'd reset the ship, and then we'd drift again, and then reset the ship and drift again. But basically, we have time series measurements from the ship, from the Woods Hole buoy that had, again, ocean and atmosphere measurements, and then the mooring, all within, a few degrees of one another. The ship and the buoy are a little closer, mooring's a little further, but yes, so that's what we were doing. Just to give you some dates, hold on, don't come back yet, Eric. So basically 6th June to 18th June, we were doing these drifts, so it's a couple week time series. And then after that, we recovered everything and ran back out of the bay. What's sort of interesting is that initially when we were out at sea, it was very active precipitation, and then by the end of that short period, it was no longer raining. And so we're kind of in this transition between an active phase and a break phase of the intraseasonal oscillations. So the exact dates that the ship was out are from the 5th of June to the 22nd of June. The sort of time series mode was from the 6th to the 18th of June. But the idea is a lot of our groups will kind of look particularly around that window, but also setting that time window in the context of the full summer monsoon season.
I don't need that. I'm wired, man. But I need this pointer. Okay, so thank you, Emily. That was lovely. So think about what Emily said, and think about what she said compared to Bot's talk earlier today. What would you, besides that one was meteorological and one was oceanographic, there's a really fundamental difference between what he was talking about and what Emily was talking about. So tell me what that difference was. What was the big differences between the way that they were looking at this system? Exactly. That was exactly what I was aiming at. These ship measurements, it's a very we're focused on maybe a month, less than a month, because people run out of food after a month. They want to go back home. They don't want to stay out there forever. And yet we were hearing first talk this morning about scales were way bigger. Probably the smallest scale that we heard about was something about maybe that big, the Central Bay of Bengal. Well, here we're talking about differences of maybe differences that are ranging from a few tens of kilometers to smaller than that to maybe 100 kilometers or something like that. So a fundamental question which we will explore in these workshops is, do you see the same thing when you're looking at this scale than when you're looking at that scale? And you can see that we have tools to address that question. There are moorings that go from 6 north here to 18 north, so that's 10 degrees, it's 1,000 kilometers. That's fairly large scale. We have separations that are really quite small. We have measurements here that are taken every few minutes probably, and we have measurements that go for many years. In the same way, there are remote sensing products which go for many, many years. On a fairly large scale, and then we have these small scale and moorings. So one of the central questions is, if you look at, does it make any difference? Does anybody care whether or not you're making measurements that are 100 kilometers apart, and can you do everything with measurements that are 1,000 kilometers apart? And different groups will look at different scales, and then we will hopefully find out something about those questions. So to move on to that more specifically, I think this does it. Okay. So we tried to organize these projects into sets of questions. 1, 2, 3 sets of questions with sub-questions. And each of these has 2. So you see 3 times 2 is 6, because that's how many blind men there were. We also gave each of them the name of an Indian harvest festival, which I don't know anything about. So anyway, so the first question is, if you think of large scales, in other words, the type of thing which we heard in Bot's lecture, thinking about the entire Bay of Bengal, what's the difference between, well, so we're sort of missing the top. What's the difference between the north and the south and the east and the west? And what's the difference between summer and winter? So this set of questions have to do with that. If you use those sort of measurements, what do you say? What do you see happens? And so that's broken down into 2 components, which is group 1A, or PONGAL, and that leader for that is Leah. Wave Leah, in case you forgot who Leah is. And this is focused on reanalysis products. So the absolutely wonderful thing that you can do now that you couldn't do, say, when I was a graduate student, is you can go on the web and you can find all sorts of files you can download for the web, mostly for free, which purport to say what's going on in the ocean and the atmosphere. That's what they do. It's really wonderful. And they've got various names, and we've downloaded several of these. And so what do they say? And there's also, because we have atmospheric stuff and we have ocean stuff, we've tried to define a set of similar metrics. In other words, we have lots of different ways of measuring it. And some people like to use long wave radiation, and some people like to use sea surface height. And so we've tried to focus this around using a common set of measurements which are associated with the fluxes of momentum, heat, and moisture across the sea surface, which isn't usually the way that everybody does it. But if you can't compare unless you're all measuring the same thing. So that's another sort of baseline here. So take a bunch of the reanalysis products, say what happened, and in particular ask, 2018, was that a strong year, a weak year, an early year, a late year? I mean, that answer is probably no, but let's look at that within the context of these products. And that's the idea of this group. Second group is there's remote sensing, direct satellite measurements, measure sea surface height, wind speed, microwave, SST, and temperature and salinity, do the same thing. With an extra emphasis on all those complicated eddies because its altimetry is pretty good. And that's Niraj, wave. Oops, he's not here. Wait, that was a trick question. He's coming tomorrow. We'll fill in for him today. Okay, second set of questions is now focusing, instead of on products, on the type of measurements which Emily was describing and were in that map. So these are actually measurements at a single point. You know, they're actually measuring something that's about that big as opposed to measuring something on a much larger scale. So that's got two groups. One which is looking at large scale, in other words, looking at the various moorings and say, well, you know, when did it start raining here and when did it start raining here? When was, you know, that's when did the wind start blowing here and here? That sort of question. And similarly, there's a one more. Similarly, there were the measurements that Emily just talked about on quite small scale. And in particular, there are there's a ship, a profiler, and a Rama mooring that are about, 100 kilometers apart, roughly speaking. So is there any difference between 2 points that are 100 kilometers apart? Do we really care about that or not? That's another part of this. We'll see how far we get. And then finally, it's nice to describe what happens, but science also involves understanding. In other words, not just what happened, but why. So there's a what of the world and there's a why. The first two groups are about what, and this one is about why. Now, why is a complicated business, and we didn't think we could do everything, but we thought of two well-defined questions. There are, Emily talked a little bit about this, and we'll hear a talk tomorrow about, these are called one-dimensional mixed layer models. In other words, when the wind blows, you mix up the ocean. Ekman transports, things like that. Those models are pretty simple to run. We've brought these models along. We have code to do it. We have air-sea fluxes. You see over the course of the ship experiments, for example, that the ocean cooled. Okay, is that in response to the amount of wind that was blowing and the amount of mixing that happened or not? It's a well-defined question that you can do in a couple of days. So that works on that. And then Manny brought along a model that describes near inertial currents. We'll hear more about that. And there are a bunch of moorings and a bunch of ships that measure near inertial. Those are velocities at the near inertial, at the Foucault pendulum frequency, at inertial frequency. And can we pair this model with what we see and make anything line up? So that's 6 projects. Just to remind you again, we're trying, there are 6 groups, and these groups need to talk to each other. Because, for example, in these people are supposed to figure out how whether the change in upper ocean temperature and salinity, volunteers who volunteer to give that talk, if you feel brave or not. So, given that, ta-da, we now get to find out what group people are in. Before that, ask me questions about this process. It's imperfect, but it will hopefully work. Any questions? No, that's good. Okay. Over breakfast, we decided what the groups are based on your input. You'll talk about what you found. Maybe you found something, maybe you didn't. It's the process of getting there that's most important. There is no test, there is no grade, although some people get more candy than others. Small price. We're going to try to put all those pieces together and prepare a summary talk for the workshop. There will be some